Hello everyone, welcome back to ST Physics. In the last video, we learned current divider rule. Today, let's understand its twin, voltage divider rule. Another powerful shortcut for circuit analysis in NEET, JEE and class 12 exams. Let's look at the shortcut. Whenever resistors are connected in series like this, the total voltage applied divides across the resistors. That is nothing but V is equals total voltage applied is equals to the voltage drop across. Let me consider the voltage drop across R1 is V1 and R2 is V2, and here total voltage divides across this combination, that is V equals to V1 plus V2. The key idea you need to keep in mind is that if the larger the resistance, then the greater the share of voltage it will get. That means if R1 is greater than R2, then V1 is equals to V1 is greater than V2. Larger the resistance, larger the share of voltage it gets. That is the thing. And here V1 is equals to the total voltage applied across the combination to the resistance across which the voltage to be determined divided by sum of the resistances, that is the total resistance of the combination. In the same manner, V2 is equals to total voltage applied across the combination times the resistance across which voltage to be determined, that is R2 upon resistance, total resistance of the combination, that is R1 plus R2. This thing, how can we get this one? Here we know that V1 is equals to IR1, but we know that I is equals to V by R equivalent. R equivalent means R1 plus R2. Here if you substitute here in place of I, then I get V divided by R1 plus R2 into R1. This is what we can take. So that we can take V1 is equals to V times R1 divided by R1 plus R2. Similarly, we can get V2 also. That means the voltage drop across the one resistor is equals to total voltage applied across the combination to the resistance across which voltage to be determined to the sum of the resistances. This is the thing. Suppose if there are three resistances connected in series, then we can take directly here. Let me consider the V1 is the voltage drop across R1 and V2 is the voltage drop across R2 and V3 is the voltage drop across R3. Then according to voltage divider rule, we can take V1 is equals to the total voltage applied across the combination times the resistance across which voltage to be determined, that is R1 divided by sum of the resistances. If there are n number of resistance, then we can take summation of R. Suppose if you want to find out V2, then V times total voltage times the resistance across which the voltage to be determined and sum of the resistances. In the same manner, we can take V3, V R3 divided by R1 plus R2 plus R3, or if there are n number of resistance, we can take summation of R. Notice something interesting here. The voltage drop across any resistor depends on its own resistance directly. If it's more resistance, then the larger the share of voltage it gets. That is the thing you have to keep in mind. Okay, and this is applicable only for series circuits. It works on the series circuit only. It is not applicable for parallel circuits. Okay, so let me make this concept more clear by solving some numericals. So in this problem, we need to find out voltage drop across the 1 kilo ohm resistor. This is a series circuit, so we can use directly a voltage divider rule. Here we know that voltage across 1 kilo ohm resistor is equals to total voltage applied across the combination, that is 5 volt, times the resistance across which voltage to be determined, that is 1 kilo ohm, divided by total resistance, that is 4 plus 1. And here 4 plus 1 5 and 5 get cancels, we get 1 volt. In this way we can find very easily the voltage across the any resistor. Here the voltage across this 4 kilo ohm resistor, that is equals to V voltage drop across 4 kilo ohm resistor is equals to total voltage applied across the combination, that is equals to 5, and here the resistance across which voltage to be determined, that is 4 divided by total resistance, 4 plus 1, 5. Here total voltage drop across this 4 volt 4 kilo ohm resistor is 4 volt. Okay, in this way we can use voltage divider rule. Let me go to the next problem. In this problem we need to find out the value of R1, and here the two sources are there, voltage sources, which are connected in opposite order, a plus and plus, and this 70 volt is connected to this combination R2, and now we can apply voltage divider rule for this. Now R2 equals to R voltage across R2 is equals to total voltage applied across this combination, and R2 divided by R1 plus R2, and by substituting we can get VR2 is equals to voltage drop across this R2 is 20 volt, and here V equals to 70, and here R2 by R1 plus R2. On solving this one, we will get 20 R1 plus 20 R2 is equals to 70 R2, and this is equals to 20 R1 is equals to 50 R2, or else 2 R1 is equals to 5 R2. Now look at this, the current passing through this one is equals to I is equals to, here we can take the current is equals to the total EMF. They are connected in opposite order, so that we can take 100 minus 70 volt divided by the resistance is 60, so that we get 1 by 2 amps. And we know that I of R1 plus R2 here for this combination, IR is equals to V, and here I is equals to how much we got, 1 by 2, and R1 plus R2 is equals to, so voltage applied is 70, and we will get now R1 plus R2 is equals to 140, and if I substitute here R2 is equals to how much, R2 is equals to 2 R1 by 5. So if I write here R1 plus 2 R1 by 5 is equals to 140, and this is equals to 5 R1 plus 2 R1 is equals to 700, and this is equals to 7 R1 is equals to 700, and R1 is equals to 100 ohm. Okay, let's go to the next problem. So look at this question. We need to find out voltage across 10 watt bulb. Here these two bulbs are rated like this, 200 volt, 10 watt and 20 watt. So if you want to apply voltage divider rule, first you need to find out resistances of this. Let me consider this is R1 resistance and this is R2. And now we know that power is equals to V square by R. V square by R. This implies that R is equals to V square by P. Now R1 is equals to, by using this formula we can find out R1. R1 is equals to V square equals to 200 into 200 divided by power, that is 10 watt, and this is equals to, so 4000 ohm. And in the same way R2 is equals to V square, here the rated voltage is 200, so 200 into 200 divided by the power is 20 watt, so this get cancelled, we get 2000 ohm. Now we got R1 and R2. Now we can find out the voltage drop across this 10 watt bulb by using voltage divider rule. We know that voltage drop across this R1 is equals to total voltage applied across the combination, that is 120, and the resistance for which or across which the voltage to be determined is how much we got here, 4000 divided by total resistance, that is 2000 plus 4000, and this is equals to 120 and 4000 divided by 6000. This and this get cancels, we get 80 volt. This is the voltage drop across 10 watt bulb. In this way we can solve numericals easily by using voltage divider rule. Now try to solve the practice question on the screen and post your answer in the comment section. Let's see in the next one. Thank you.